IXL Section BB.13, Graph quadratic functions in standard form. Let's do a quick review of some important concepts when it comes to graphing quadratic functions that you're going to need in this chapter. Okay, so the first thing I want to go over is remind you about the axis of symmetry. Okay, so right here we have two parabolas. Those are the graphs of a quadratic function. Okay, so the axis of symmetry is a line that divides the parabola into two halves. Okay, that's the axis of symmetry. Over here, this is the axis of symmetry. It's a line that divides the parabola into two equal parts, two equal halves. Okay, now notice that the axis of symmetry lines up with the vertex. Here's the vertex, and here's the vertex. The axis of symmetry is always going to be x equals a number. The axis of symmetry is always x equals a number. That number is the x coordinate of the vertex. Okay, so like once I know the axis of symmetry, let's pretend that this is at 2. X equals 2 is the axis of symmetry. That means that the x coordinate of the vertex will be 2 comma whatever. I'll say it again. If I know that the axis of symmetry is located at x equals 2, this is the x coordinate of the vertex. That would mean that the coordinate of the vertex would be 2 comma something. All right, so the axis of symmetry is always the x coordinate of the vertex. This should be a review because I already gave you several IXLs that involve this before spring break. So hopefully you did them. If you didn't do them, you're probably a little lost right now. Or maybe a lot lost, but that's your fault. Okay, now, why am I going over that? Because in this IXL, we're going to be graphing quadratic functions in standard form. As you can see here in red, for this IXL, you only have to get to 90 points. All right, so get to 90 points, and that'll be 100 in the gradebook. Okay, now, I'm going to show you how to do the problems in a moment. They're not difficult. But I wrote here the steps in case you want to see. I'm going to do the same steps on every problem. Okay, they're going to give us, let me show you what the problems look like first of all. They're going to give us this. They're going to give us a quadratic function. And you got to graph it. So it even tells you in the directions what to do. First thing you got to do is plot the vertex. And then after you plot the vertex, you got to plot another point on the parabola. So once you plot the vertex, then you plot another point, and IXL will fill out the graph. All right. Now let's go back to my instructions here. So this is what I'm going to do on every single one. First, I'm going to plot the vertex like the instruction says, and then I'm going to plot another point on the graph. Now, how am I going to plot the vertex? Okay, the way I'm going to plot the vertex is by first finding the x coordinate of the vertex by finding the axis of symmetry. How do I find the axis of symmetry? Using this formula. If you forgot how to do it or you never did it, I'll go over it in a second. But I'm going to use that formula to find the x coordinate of the vertex. Because the x coordinate of the vertex is the same as the axis of symmetry. All right? And then once I find the x coordinate of the vertex, I'm going to substitute the x coordinate of the vertex. Substitute the x coordinate of the vertex into the function in order to find the y coordinate of the vertex. Again, I'll demonstrate this in 1 second. Okay, and then once I plot the vertex, step 2 is I got to plot another point on the graph. So there's two things you could do. The first thing you should always try is to plot the y-intercept. The y-intercept, notice that I put everything in blue and then this part in red. I put this part in red because this, whenever it's in this form, a quadratic function, this is the y-intercept. Why is this the y-intercept? Because when you make these x's equal to 0, remember the y-intercept is what is y when x equals 0. When I plug in a 0 there and a 0 there, all of this cancels out, and whatever number is here is the y-intercept. So once you realize that, you could just look at it and be like, oh, this is the y-intercept, whatever number is here. So the first thing you should do is check, can I plot that? If you could do that, then that's it. You just do that. But if you can't do that, then you're going to have to try to substitute another value for x that's near the vertex. All right, so let me demonstrate what I mean by all this. Let's look at the first example. All right, so if you, in my instructions, I put, first we got to plot the vertex by finding the axis of symmetry using this formula. All right, so here's my formula to find the axis of symmetry. Okay, now, in this quadratic function, what is A, what is B, and what is C? A is the number in front of x squared, so A is 5. B is the number in front of x, so in this case, negative 20. And C is the constant that's back here, which is positive 15. So those are my values for A, B, and C. Now I'm just going to plug in the values of A and B into this formula. So the formula says negative B, so it's going to be negative 20 over 2 times A. A is 5. Okay, so negative 20 becomes positive 20. And 2 times 5 is 10. And 20 divided by 10 equals 2. So the axis of symmetry is at x equals 2. The axis of symmetry is right here at x equals 2. This is where the axis of symmetry is. Okay, but that's also the x-coordinate of the vertex. So the x-coordinate of the vertex is 2. Now I got to find the y-coordinate of the vertex. How am I going to find the y-coordinate of the vertex? Well, by substituting 2 for x and seeing what do I get for y. In other words, when you plug in the number 2 into this function, what do you get for y? All right, so let me do that. F of 2 equals 5 times 2 to the second power minus 20 times 2 plus 15. Are you going to have to work this out on paper? Guess what? Yes. Don't be lazy. You got to work it out on paper because I have to work it out on paper. But guess what? This is all over your upcoming Algebra 1 exam, so that's why I'm putting it for you. So be smart and do it because it's important. I'm not wasting your time. It's going to come up a lot. Or the other option is just fail everything and just go to summer school. That's because that's always a really smart option. Okay, so let me work this out. I'm going to follow the order of operations and do 2 to the second power, which is 4. All right, and now I'm just going to multiply from left to right. So 5 times 4 is 20, and negative 20 times 2 is negative 40. And now I'm going to add and subtract from left to right. 20 minus 40 is negative 20, and negative 20 plus 15 is negative 5. So in other words, when x is 2, y is negative 5. That is my vertex. When x is positive 2, y is negative 5. So that's the first thing I'm going to plot. Okay, now if A is positive, which it is, that means that the parabola opens up. So the parabola is going to be opening up. Now, the next thing you should try to do is now we got to plot another point that's on the parabola. Now, in my instructions, I put the first thing you should try to plot is the y-intercept, which is this number. However, the problem in this case is that positive 15 is outside of our graph. So I can't use that number because it's not here. It's up here somewhere. So instead, let's try if x equals positive 1, what do I get for y? Again, I'm going to try if x equals positive 1. You could have also tried if x equals 3 or if x equals 4. But I'm going to use if x equals 1 because it's an x value near the vertex and it's a pretty easy number to work with. Okay, now in order to do that, let me erase what I have here. The vertex is at 2, negative 5. So 2, negative 5. By the way, I'm taking long because this is the first example and I'm trying to spell everything out. All right, but they don't take as long as I'm taking right now. All right, so the vertex is at 2, negative 5. All right, so let's try if I substitute x equals 1 into the function. What do I get for y? So if I plug in x equals 1, I'm going to have 5 times 1 to the second power minus 20 times 1 plus 15. Now, that's going to be 5 times 1 minus whatever, 20 times 1 plus 15. So this will be 5 times 1 is 5. Negative 20 times 1 is negative 20 plus 15. And if I go from left to right, 5 minus 20 is negative 15. Negative 15 plus 15 equals 0. So in other words, when x equals positive 1, y is 0. So there's another point on the graph. So I'm just going to put that point and this point, and IXL will do the rest. It'll probably be something like that. All right. All right, let's look at another example, and I'll try to go a little quicker. All right, so here we have another example. So again, step 1 is to find the vertex. How am I going to find a vertex? By first finding the axis of symmetry using this formula. You need to memorize this formula because they don't give it to you on the geometry you'll see. And I'm telling you, after you use it a couple times, you'll remember it. It's not difficult at all. So in this quadratic function, a equals 4, b equals 8, and c, you don't need it, but just in case, just so you know, c equals 9. All right, so when I substitute those values, I'm going to have x equals negative 8 over 2 times 4. So negative 8 over 8. Whoops, negative 8 over 8. So my axis of symmetry is at x equals negative 1. That means that the x-coordinate of the vertex is x equals negative 1. Now I need the y-coordinate of the vertex, and the way I'm going to find it is by substituting the x-coordinate of the vertex into the function to see what I get for y. So I'm substituting negative 1 into the function. All right, so when I do this, negative 1 to the second power is positive 1, and 1 times 4 is 4. Negative 1 times 8 is negative 8. Now I add and subtract from left to right. 4 minus 8 is negative 4. Negative 4 plus 9 is positive 5. So when x equals negative 1, y equals positive 5. That's my vertex. When x equals negative 1, y equals, when x equals negative 1, y equals positive 5, which is right there. Okay, now a is positive. That means that the parabola opens up. It's going to open up. Okay, now look, on this one, I could just do the other part really quickly. Right there is the y-intercept, and I could graph it. It's right there. So that's it. I'm done. This one was a lot quicker. All right, so there's my parabola. It's not that hard, guys. It just takes like 2 steps that you got to do. All right, let's look at another one. Okay, so again, first step, let's find the x-coordinate of the vertex by finding the axis of symmetry. So in this quadratic function, a is negative 1, b is negative 4, and c is negative 8. When I substitute those values into this formula, I'm going to have negative 4 over 2 times negative 1. That's going to equal positive 4 divided by negative 2, which equals negative 2. So the x-coordinate of the vertex is negative 2. Now I'm going to find the y-coordinate of the vertex by substituting negative 2 into the function and seeing what I get for y. Okay, so when I do that, negative 2 to the second power is positive 4, and I put this negative sign in front of it, making it negative 4. Negative 4 times negative 2 is positive 8, and I got minus 8. So when we go from left to right, negative 4 plus 8 is positive 4, and positive 4 minus 8 is negative 4. So when x equals, sorry, this thing is messing up. When x equals negative 2, y is going to equal negative 4. So that's my vertex, negative 2, negative 4. Now is the parabola opening up or opening down? Since our a value is negative, the parabola opens down. Check if you could plot the y-intercept. Yes, you can. The y-intercept is at negative 8. That's it. I'm done. The y-intercept is at negative 8 right there. And IXL will do the rest, but on the other side, it should have a point right there as well. All right, and there's your parabola. Okay, next example. Again, first step, find the x-coordinate of the vertex by finding the axis of symmetry using that formula. Memorize that formula, negative b over 2a. In this quadratic function, a is positive 3, b is positive 12, and c is positive 14. All right, so I substitute the values into the formula, and I'm going to have negative 12 over 2 times 3. That's going to be negative 12 divided by 6, which gives you negative 2. So the x-coordinate of the vertex is negative 2. Now I'm going to find the y-coordinate of the vertex by substituting negative 2 into the function. And when I substitute negative 2 into the function, I'm going to have this. All right, so negative 2 to the second power is positive 4. 4 times 3 is 12. 12 times negative 2 is negative 24. Okay, now from left to right, 12 minus 24 is negative 12, and negative 12 plus 14 is positive 2. So when when x equals negative 2, y equals positive 2. So that is our vertex, negative 2, positive 2, negative 2, positive 2. Now is the parabola opening up or opening down? Since a is positive, the parabola is opening up. Okay, now here we have a problem because we can't plot the y-intercept at positive 14 because it's up here somewhere. So instead, I'm going to have to substitute another value for x in order to see what do I get for y. So the one I'm going to do is when x equals negative 1. All right? So to try to get a point somewhere here that's on the parabola. So when x equals negative 1, let me do it down here. All right, when x equals negative 1, if I substitute that into the function, I'm going to have 3 times negative 1 to the second power plus 12 times negative 1. Sorry guys, my writing tool is messing up. Really frustrating to try to do a video like that. But all right. Okay, so negative 1 to the second power is positive 1. 1 times 3 is 3. Over here, negative 1 times 12 is negative 12. All right, now if I go from left to right, 3 minus 12 is negative 9. Negative 9 plus 14 is positive 5. So, positive 5, sorry. So when x equals negative 1, y equals positive 5. So there's the other point that I needed on the parabola, which will also be on the other side of the parabola. All right? And again, IXL will do the rest. So there's my parabola. All right. Next example. I'm going to do one more like this and then 2 examples with fractions that are not difficult. Well, maybe a tiny bit difficult, but they're totally doable. All right, so let me do one more like this, and then I'm going to do 2 with fractions. So again, step 1, I'm going to find the x-coordinate of the vertex by finding the axis of symmetry with that formula that you should have memorized. In this quadratic function, a is negative 6, b is positive 12, and c is negative 4. So when I substitute those values into the formula for the axis of symmetry, I'm going to have negative 12 divided by 2 times negative 6. That's going to be negative 12 divided by negative 12, which gives you positive 1. So the x-coordinate of the vertex is positive 1. Now to find the y-coordinate of the vertex, I'm going to substitute positive 1 into the function and see what do I get for f of 1. So when x equals 1, I'm going to have negative 6 times 1 to the second power plus 12 times 1 minus 4. So that's going to be negative 6 plus 12 minus 4. If I go from left to right, negative 6 plus 12 is positive 6. Positive 6 minus 4 is 2. So f of 1 equals positive 2. So there you have your vertex. The vertex is located at 1, comma 2. Okay, now does the parabola open up or down? Since a is a negative number, the parabola is going to open down. Now, the easiest other point to try to plot on the parabola is the y-intercept, which is always this number. So in this case, that's really easy. Just put a dot at negative 4 and you're done. IXL will do the rest. The parabola is going to have a dot on the opposite side over here. And there's my graph of my parabola. All right. Now let's jump to some examples that have fractions. All right. Let me skip this one because I've already done. All right. So let me do two that have fractions. These two are not that difficult at all. Okay. They don't really get difficult until you get into the challenge zone. But these come out before the challenge zone, so they're important to pay attention to. All right. My process is going to be exactly the same. And I will give you a couple tips to make it easy for you. All right, so first of all, I'm gonna find the find the x coordinate of the vertex by first finding the axis of symmetry using this formula. In this quadratic function, a is positive 1/2, b is 3, and c is 11/2. Get used to always knowing that this is the y-intercept, okay? I'm telling you, that'll help you out on a lot of questions on the exam. I've seen questions on the Algebra 1 EOC where they're literally asking, like, what's the y-intercept? And the answer's right there, and I see kids doing a ton of calculations and not getting it when they don't have to do any calculation. The number that's right here is the y-intercept always. All right, so make sure you realize that. Anyways, when I substitute the values into this formula for the axis of symmetry, I'm going to have negative 3 over 2 times 1/2. All right. Here the fraction is going to cancel out because 2 times 1/2, these 2's cancel out and it ends up giving you negative 3 over 1, which is negative 3. All right. So the x coordinate of the vertex is negative 3. Now to find the y coordinate, I'm going to substitute negative 3 into the function to see what do I get for y when x equals negative 3. All right, so I'm going to have this. I'm writing slow to try to make sure that my writing tool works good. Because if I go fast, it starts messing up sometimes. All right, so I have this. All right, now let's work this out. Negative 3 to the second power is positive 9. And 9 times 1/2 is going to give me 9/2. Over here, 3 times negative 3 is negative 9. You know what? To save space, 3 times negative 3 is negative 9. Now, how do I write negative 9 so that it'll have a 2 on the bottom? In other words, what number divided by 2 will give you negative 9? What number divided by 2 will give you negative 9? Negative 18 divided by 2 will give you negative 9. All right, so there, I just changed it into a fraction that has the same denominator as this one so that I can combine them easily. And this, the last number in our function already has a 2 in the denominator. So now I can combine this kind of quickly. All right, so let's go from left to right, and the 2 will stay in the bottom, okay? So on the top, 9 minus 18 is negative 9, and negative 9 plus 11 is positive 2. And what's 2 over 2? 1. So when x equals negative 3, y equals positive 1. All right, so negative 3, positive 1, that's where our vertex is. Okay, now since a is positive, the parabola is opening up. Okay, now here I want to tell you something very important, and please listen because this is going to make your life a lot easier, the tip I'm about to give you. All right, I have my vertex plotted, and that really wasn't that difficult because all the fractions ended up getting eliminated. Okay, now I said that the easiest point to plot next would be the y-intercept, which is 11/2. Now you might think that because it's a fraction, you can't use that one to plot it, but IXL will accept it if it's if it's either a whole number or right in the middle. If it's a number, if it's whatever 0.5. So if it has a number 0.5, IXL will accept it in your graph. And that's what we get when we divide 11 by 2. 11 divided by 2 equals 5.5. All right? So my point is I am able to just plot the y-intercept. All right? Man, this is messing up. Sorry. It's not me. It's the tool I'm using. And I don't know what the trick is to fix it. Except like unplug it and plug it back in. All right, so anyways, the y-intercept is this number, this fraction, which when you change it to a decimal is 5.5. So that would be right here, right in the middle between 5 and 6. So if you put that in IXL, it accepts it. So that will make this problem a lot easier because I don't have to keep searching for another point to plot, because that's what makes it difficult. Okay, because it's kind of hard to find another one when you're using fractions. All right, but for this one, before you get to 90, you get situations like this that are doable, especially with what I just mentioned. All right, I'm going to do one more with fractions, and this will be the last example. All right, so one more example with fractions. Let me make sure it's different. All right, so again, let's first identify A, B, and C. A is negative 1/2. B is negative 3. And C is negative 25/2. And that's the y-intercept. Okay, so first thing I'm going to do is find the x coordinate of the vertex by finding the axis of symmetry using this formula. When I plug in the values, I'm going to have on the top negative 3. On the bottom 2 times negative 1/2. All right, so on the top you're going to get positive 3. On the bottom, a positive times a negative equals a negative, and these twos cancel out, so you're going to have negative 1 on the bottom. So 3 divided by negative 1 equals negative 3. So that's the x coordinate of the vertex, negative 3. Now I need the y coordinate, so let's substitute negative 3 into the function to see what we get. So when x equals negative 3, I'm going to have negative 1/2 times negative 3 to the second power minus 3 times negative 3 minus 25/2. I think some of these numbers are similar to what we just saw a little while ago. But all right, so here, negative 3 to the second power is positive 9. Positive 9 times negative 1/2 is going to be negative 9/2. Here, negative 3 times negative 3 is positive 9. However, I want it to be a fraction with a 2 on the bottom. So what number divided by 2 equals positive 9? 18 divided by 2 equals positive 9. Okay? And here, let me just bring this down. Now I could go just from left to right, adding and subtracting, and let's keep the 2 in the denominator. So negative 9 plus 18 is positive 9, and positive 9 minus 25 is going to be negative 16. Positive 9 minus 25 is negative 16. Negative 16 divided by 2 is negative 8. All right, so that's our vertex. When x equals negative 3, y equals negative 8. Okay, so negative 3, negative 8. Now, is the parabola going to open up or down? Since a is negative, the parabola is going to open down. Now, we need another point on our parabola, so let's try to plot the y-intercept, which is at negative 25/2. What's 25 divided by 2? All right, an easy way to do it is just do 24 divided by 2. 24 divided by 2 is 12, and then just add 0.5 to it. So it's going to be negative 12.5. Negative 12.5. All right, so that does not fit on our graph. So I'm going to have to use another point. All right, let's try when x equals negative 2. All right, but I got to make space here because I have a disaster here. So let me erase my vertex is at -3, -8. So let me erase everything. The vertex is at -3, -8, which is right here. All right, so I said I'm gonna try. We gotta try. You should try x values that are near the vertex, so that they'll land. So they're more likely to be able to fit on your graph. All right, so I'm gonna try x equals -2. So when I substitute -2 into the function, I'm gonna have this. Yes, this is a little bit of work, but that's life. Actually, life is a lot of work, but you get my idea. You get what I'm trying to say. All right, so anyways, right here, -2 to the second power is +4. 4 times -1/2 is going to be -4/2, and -4/2 is going to equal -2. Okay, now here, -3 times -2 is +6. All right. Okay, let's just leave it like that. And right here I have -25/2. I probably should have just left this as a fraction. So let me change -2 back to what it was before. Or you can think about it this way. I need to have a 2 on the bottom. One number divided by 2 equals -2. -4 divided by 2 equals -2. All right. And what number divided by 2 equals 6? 12 divided by 2 equals 6. Or you could just do 2 times 6 to get that 12. All right, anyways, you got to have the same denominator in order to add or subtract fractions. So now they all have a 2 in the denominator. So I could just go from left to right. -4 plus 12 is +8. +8 minus 25 is -17. Okay, so so I'm going to use this. This is going to work, all right? When x equals -2, because remember I said that if it's a whole number or a number 0.5, IXL will accept it. Well, -17 divided by 2 is -8.5. Okay, -17 divided by 2 is -8.5. So when x is -2, y is -8.5. So I'll put this point exactly in the middle between -8 and -9, and IXL will accept it and do the parabola. There'll be the same point on the other side. Okay, and there's my parabola, guys. And that's it. I'm done with this problem. And I'm also done with this lesson, guys. This is a really important lesson. Make sure to do it. Yes, it involves some work, guys, but don't be lazy. That's the only way you're going to get good is by doing the ones that are a little bit challenging. They can't all be 5-minute IXLs that you could knock them out real quick. Some of you guys can't even do the 5-minute IXLs because that's 5 minutes is too much work for you. That's how lazy some of you have gotten. All right, but the only way you're going to ever get good at something is by doing, stuff that's challenging, by making yourself struggle a little bit. All right, that's how your muscles grow, both your physical muscles and your mental muscles in your brain. You got to stress them out. Okay, and I'm already trying to help you out by making it that you just got to get to 90 points. So as long as you stop when you get to 90, these should be the most challenging problems you get, where they have fractions, but they're doable. They're not that difficult. All right, so I highly encourage you to do them because this type of stuff is on your test that you're having next week in your Algebra 1 class, and you're finishing it in my class. And there's a lot of stuff like this on the Algebra 1 EOC as well, which is a very challenging test, and you need it to graduate, as I've said many times. All right, guys, that's it for this lesson. Hope you guys have a great rest of your day, and I'll see you guys next class. Have a great day.